This particular piecewise function has three equations and three different intervals for which x can equal something. So let's go ahead and start out by making three t-tables. X plus 3 will be our first, y equals 6 will be our second, and y equals negative x plus 2 will be our third. Okay, so if I look at my intervals here, I see that the x plus 3 equation has to be between negative 2 and 1. So I'm going to use those two numbers. And I also recognize that at the 1 we're going to have an open circle. So let's calculate those values. Negative 2 plus 3 is 1, and 1 plus 3 is 4. So I'm going to plot those 2 points, and I don't have my graph paper with me right now, so I will just sketch a graph. Nothing like being unprepared, huh? Okay, so I'm going to graph the point negative 2, 1, and I'm going to graph the point 1, 4. And x is only between those two numbers. So I'm just going to draw the segment that goes between those, remembering that the point 1, 4 has to be an open circle. Now for y equals 6, if x equals 1, well, we only have one x value that we can use, and we know y equals 6. So I'm going to just plot the point 1, 6. That's all I'll do for that middle portion. And for the negative x plus 2, x must be greater than 1. So I'll choose a 1 and a 2, remembering that I'll have an open circle at the 1 because its x is greater than 1, not greater than or equal to. So negative 1 plus 2 is 1. Negative 2 plus 2 is 0. So I will plot 1, 1, and I will plot 2, 0, and this is open-ended. It's any point greater than 1. So I will draw an arrow. And that is the graph of this particular function. You'll notice that we have 3 points for where x equals 1. But only one of those points is closed in. So if you were to do the vertical line test, we would only pass through one point at that particular place. Okay, so our domain, we started at negative 2, and we went to 1, and then we went to greater than 1. So our domain is negative 2 to infinity. Our range is a little bit different. Our lowest point on the graph is negative infinity. Then we went up here to 1 right here, but this is also the point negative 2, 1. So we go to 1, and then we go to here, which is a y value of 4. So negative infinity to 4. And then we have one point that has a y value of 6. So that looks a little bit different than what we've done before. And is this a continuous function? No. It's not continuous because we have a break here and we have a break here. Continuous would mean we would not have any breaks. It would be similar to the last example that we did.